Okay, I welcome you once again to Kenyaku Mathematics Classroom. And this is the continuation of binomial expansion. But in this particular episode, I'm going to teach you how to use the combination approach to also solve the binomial theorem or binomial expansion. Now, we have, if you have a plus x exponent n, now the combination approach, this is given by n combination 0, a exponent n plus n combination 1, a exponent n minus 1 x plus n combination 2, a exponent n minus 2 x squared plus n combination 3, you have a n minus 3 x cubed up to a term in x exponent n or a exponent n minus r x r. Okay, so this is the combination expression for solving binomial expansions. This is the combination expression for solving binomial expansion. So if you are given an expansion, a binomial expansion, you can also use the combination approach to solve this problem. Now I'm going to explain this to you. So this is n combination 0, this is n combination 1, this is n combination 2, this is n combination 3. In that order, it depends on the highest exponent. That will tell you where you are supposed to stop, or the question can tell you where to stop. Now, this is the first term, this is the second term, this is the third term, this is the fourth term, in that order. So, if you are asked to expand up to the third term, then 1, 2, 3. When you get to the term in x squared, you have to stop. If you are asked to expand to the fourth term, then you have 1, 2, 3, 4. When you get to the x cubed term, you have to stop. But if you are not asked to stop anywhere, then it means you have to check your exponent. That will tell you where you are supposed to stop. So this is the combination approach for solving. This is a combination formula for solving binomial expansions. Now, we will be looking at the question and see how best you can use this to solve the question. Now, let's assume that you have 2 plus x exponent 3. This will now be, take note that this is our a. So our a is 2 here. You can see that our a is 2 here. Our x is still our x here. It hasn't changed. And our n is now our 3 here. So where you see a, you have to substitute that by 2. Wherever you see x, is still your x. But wherever you see n, you now substitute that by 3. So in doing that, then n combination 0 will now be 3 combination 0. Then a is now 2. So you have 2 exponent n, and n is 3. Then you have n combination 1, and n is 3. So you have 3 combination 1. Then you have a exponent, and a is 2 exponent 3 minus 1. Then you have your x here. Then you have 3 combination 2, 2 exponent n minus 2. And that will be 3 minus 2. Then you have your x squared here. Then you have n combination 3. That is 3 combination 3. Then a, and a is 2. So 2 exponent. You have 3 minus 3. That is n minus 3. Then x exponent 3. X exponent 3. So you have to stop here because the exponent is 3. So you have to stop as a term in x cubed. So if the exponent was 4, then we have to continue. But because the exponent is 3, we have to stop here. Now, when we say 3 combination 0, or 3 combination 1, 3 combination 2, 3 combination 3, the calculator can do that very simple. But in general, when we say n combination, you can say n r. This is n combination r. This is also written as n combination r. So on your calculator, you can find this. You may not find it. You find this. This is the same as n combination r. So it means that when we say 3, 0, this is the same as 3 combination 0. When you write 3, 1, this can be written as 3 combination 1. When you also write 3, 2, this is the same as 3 combination 2. And when you write 3, 3, this is the same as 3 combination 3. Now, when we say n combination r, this is the same as n factorial over n minus r factorial. So n combination r is given by n factorial over n minus r factorial. So this will now be 3 combination 0 will be 3 factorial. Then 3 minus 0 factorial, then 0 factorial. Then this was 3 combination 1 will be 3 factorial over 3 minus 1. That is 3 minus 1 factorial, then 1 factorial. 3 combination 2 will be 3 factorial over 3 minus 2 factorial, then 2 factorial. And 3 combination 3 will also be 3 factorial over 3 minus 3 factorial, then 3 factorial. Okay, so if you want to simplify this, now 3 factorial, you know that it is the same as 3 times 2 times 1. Then 3 minus 0 is 3. So 3 factorial will also be 3 times 2 times 1. But 0 factorial is the same as 1. Take note, 0 factorial is 1. So 3 times 2 times 1 will give you 6. 3 times 2 times 1 times 1 will also give you 6. So we have 6 over 6. And 6 over 6 will give us 1. That means that 3 combination 0 is 1. So you can try this on a calculator. You realize that you are getting 1. And that's where the 1 is coming from. Then we have 3 factorial. That is 3 times 2 times 1. All divided by 3 minus 1 will be 2. So 2 factorial is 2 times 1. Don't forget that we have 1 factorial. And 1 factorial is also 1. 1 factorial is 1. So we have 2 times 1 times 1. And that is 2. So 2 can cancel because this is 3 times 2, that is 6. 6 times 1 is 6 divided by 2, and the result will be 3. Then 3 combination 2, so we have 3 factorial, that is 3 times 2 times 1, all divided by 3 minus 2 factorial is 1 factorial, and 1 factorial is 1, times 2 factorial is 2 times 1. Okay, this should be 3 times 2 times 1 is 6, divided by 1 times 2 times 1 is 2, and this will also give you 3. Then our last one, 3 factorial is 3 times 2 times 1, all divided by 3 minus 3 is 0. So 0 factorial, and 0 factorial is 1. Then times, we have 3 factorial here. That is 3 times 2 times 1. So 3 times 2 times 1 here will give us 6, divided by 1 times 3 times 2 times 1 will also give us 6, and the result is 1. So it means that 3 combination 0 is 1, 3 combination 1 is 3, 3 combination 2 is 3, and 3 combination 3 is also 1. So you can try this on the calculator. You get these same answers. So in general, n combination r is given by n factorial over n minus r factorial, then r factorial. And so we now know for 3 combination 0 to be 1. We know 3 combination 1 to be 3. We know 3 combination 2 to be 3. And we know 3 combination 3 to be 1. And so we do our substitution, and that will be all. So I want to get this off since you understand this. If you are getting a little bit confused, this is the general formula. N combination r is n factorial over n minus r factorial. And so you do that to get your combinations, then you multiply through. So since we now know this, that this is 1, this is 3, this is 3, and this is 1, that means we can get this off. So I advise that if you are getting confused, take your book, take your pen, get your time, and do the calculation. Follow what I'm doing, and you understand it. So 3 combination 0, we had 1. So we have 1 times 2 exponent 3. Then plus 3 combination 1 also give us 3. So we have 3 times 2 raised to the power 3 minus 1 is 2. Then we have our x. Then 3 combination 2 also give us 3. So we have 3 times 2 raised to the power 3 minus 2 is 1. Then we have our x squared. Then 3 combination 3 give us 1. And so we have 1 multiplying 2 exponent 3 minus 3 will be 0. Then we have times x raised to the power 3. So a step down, 2 raised to the power 3 is 8. 8 times 1 is 8. Plus 2 squared here is 4. 4 times 3 is 12. So we have 12x. Then 2 raised to the power 1 is 2. 2 times 3 is 6. 6 times x squared is 6x squared. Then plus 2 raised to the power 0 is 1. Then 1 times 1 is 1. Then 1 times s cubed will be s cubed. So this will be the expansion for 2 plus x exponent 3. Using the combination approach, this is how we solve for that. So this is how we use the combination method to solve binomial expansion. Now, this one is the same as this expansion can also be solved by multiplying 2. When we say 2 plus x exponent 3, this is the same as 2 plus x. 2 plus x times another 2 plus x. So if you remember, when we started the binomial expansion, we were looking at how to use this to solve for the expansion. So you multiply 2 plus x by itself 3 times. Now, let's multiply the first or the last. This is 2 plus x. So let's multiply this by this. So 2 times 2 here will give us 4. 2 times x here will give us 2x here. Then x times 2 is the same as 2x. And x times x here will give us x squared. Then we now multiply this by all this. So 2 will first multiply all. Then x will also multiply all. So this will be 2 plus x. Let's simplify this first. This will be 4 plus 2x plus 2x will give us 4x here. Then we have our x squared here. Then let us now expand. So 2 will now multiply 4, and that will give us 8. Then 2 will multiply 4x, and that will give us 8x. Then 2 will multiply x squared, and that will give us 2x squared. Then x will multiply 4, and that will give us 4x. Then x will multiply 4x, and that will give us 4x squared. Then x will multiply s squared, and that will give us s cubed. So this is now equal to, we can simplify, grouping the terms. The only constant we have here is 8. Then the x term, we have 8x here, we have 4x here, and that will give us 12x. So we have 12x. And the square term, we have 2s squared here, we have 4s squared here, and that will give us 6x squared. Then the only cube term we have is s cubed. So do you see that this is the same as this? So we are getting the same thing. So if you are multiplying this by itself 3 times, the answer will be the same as what we had when you use the combination approach. And don't forget that we can also use the Pascal triangle coefficient to also solve for this. And I guess you understand that. But if you are watching us for the first time, then I'll advise that you go back to the part 1, part 2, part 3, part 4, part 5 of the binomial theorem so that you can appreciate what we are doing here. So when you are given the problem, there are so many methods to solve for that. You can use this approach, you can use the expansion approach, then your answer will be out. Your answer will be out. So if you multiply this by itself 3 times, you are getting this, and this is the same as what we had here. So take note of that. Now I want to give you an exercise. Since you now know how to do the expansion using the combination approach and the other expansion methods,